I love oral shapes.
Really? Yeah.
You don't?
No.
I love it and don't understand.
Oh, okay. Good business for IT.
Actually, yeah.
Yeah.
I already find oral shapes.
So many people like to buy from it.
Mm.
金企 also.
Oral shape?
No, not oral shape, like from IT.
Yeah, the only bubble tea shop that I know.
A few more
I
around.
know, but IT is more common and cheaper.
Cheaper?
It's not?
I thought the cheapest is the Express.
Oh, this Express?
Yeah. Yeah, it's still there.
You tell me.
You try later, you can try.
Try?
Second round.
Next time.
You know the standard version is 180 only, you know. The standard. That one I don't because I don't try oral. The cheap version 180 only, you can try later second round.
Okay, let's go. Maybe this day.
Yeah, okay.
I come there.
I thought there's another one also around the corner. Is it closed already? I can't remember.
It's closed.
That one I think is closed, right?
I think Oppo only got something very close to there, right?
I think so. I hardly go to that one.
I didn't even go before they closed that.
There's one more downstairs. Is it still around? Ground floor. At near the escalator, is it still there? No. No way.
I don't see already yet.
Okay. I hardly take note of it. Yeah. Hey, Chloe, did you bring the worksheet from last week? I don't think you're finished. Yeah. I think you still have 2 more questions at the back which you haven't done yet. You check. Have you done? Have you done it? No, right? Okay. Remember that there are 3 important lines when you draw this sort of diagram. Can you remember what the 3 important lines are? That normal. That's only for reflection and refraction, but this one is not. This one is lens. Okay, come, go on. Let me turn this on first. I'll remind you. Ting can remember the 3 important lines? Can I?
No.
Yeah. Okay, of course, I'm not just referring to this question. I mean, I'm just referring to in general. So I would have the lens here. Always find out where is your horizontal line, principal axis. Where is your object? You try to find out where it is. Now, first line, parallel. Okay. Come, Mingting, your light is from left to right or right to left direction? Yes, always coming up from the object. Okay, this is the object. You also need to know where is your F focal point. Here, I'll call it F. Then, from here, you join to the focal point. Of course, using ruler. Direction, obviously, still from left to right. Now, second line is from object to this point. Same direction, left to right. This one, there's no bending. It goes straight. Even though, I mean, of course, I didn't use a ruler, so it doesn't look so nice. Now, third line. Now, there's another F point here. Okay, take note, distance from F to lens is the same from this F to the lens. So I draw from same thing, top, right downwards. Once you reach the lens, it becomes horizontal. Now, if you draw correctly, the three lines should meet at the same spot. Okay, take note, they should meet at the same point. So by right, if you draw two lines, it's good enough to identify that point. Oh, by the way, what is the point here anyway? Yeah, anything? Yeah, this is where your image is. Notice it's upside down. Okay, so it's your image. Oh yeah, I didn't draw the direction for the third line. Make sure you include arrows. If not, yeah, you'll be penalized. Okay, Chloe. Come, try to work out the last two questions. I believe you only have two more to go. Thinking all done already. Let me take a look. Make sure you got no mistake. Oh. Good.
但是按大环境，没有人看，因为看环境。给哦，一边就。
Hmm? Oh, okay, fine. I saw wrong. Good.
But actually, why?
Why what?
Why when you erase the black graph thing, you have got color something? It's my eraser problem.
If you erase it, then what happens?
That will be gone.
Oh, because you're erasing the ink also. This is printed. So there's printer ink on it. So when you erase, you remove the printer ink as well. Okay. Sorry. This one goes through the F, correct? But once it reaches here, what happens? It should be horizontal. How come it's not horizontal? It's now slanting downwards. Okay, this is remember the three lines? So once it hits here, you should draw a horizontal line. So they should intersect somewhere here. Hey, do you think that's a question? This one, the way that you drew it, it seems to point about this point here. How come you drew your image here rather than here? Oh, okay lor.
Yeah, same thing like that.
The same thing. Okay lor, in the exam, same thing. Yeah, other than that, okay.
It's wrong anything.
Yeah. This one is okay. Because this one is from here. Or from here. But then this one will be wrong. It should be about 1.5, around 1.5.
What's the range?
Yeah, 1.5. What's the what?
Range that's
I think they're pretty strict, no, because they for this one, they've given you like everything, almost everything. As long as you use your ruler to draw, you should get it right.
the image they drew for me. Not the one I drew like.
Is it? They drew one. Let me see. Oh yeah. Oh, okay. I thought you drew yourself.
No, I drew. They want to be drawn this first. If I erase the whole thing, right? Then the graph must be out. I think I don't want to. And then draw.
Hey, but all the more you shouldn't get it wrong. Let me see. This is 1, 2, 3, 4, 5, 10, 15. Then you should there's even less excuse.
2.5.
No, look carefully. Okay, that looks better.
It's like over here. Just let me.
Hold on, so you just remember this line don't draw first. Make sure you complete A and C. And then only then you can join from here to this point. Okay? Yeah, okay.
Okay, yeah. Over the error, right? It ends in the middle.
Middle? Oh, okay.
Square.
Oh,
From my point of view.
yeah, I guess so. But here, I mean, if you have
Okay, let's change.
magnification is exactly on the line.
15/10, right?
Mm.
Okay. Which is here.
Yes, upside down. Make sure you draw an image upside down. By the way, for your practical exam, if let's say you don't have the time to finish,
Okay.
but you still want to get some, or in fact, you can get full marks. The trick is, you can more or less figure out what the trend is going to be like.
Trend.
That means maybe you take how many data points? 5 data points. But if you have only time to take, let's say, 2 data points, but more or less you should know, let's say Ohm's law must give you a straight line. If it's V over I. So you know it's a straight line, right? Then you just pick some points that you haven't had time to do yet.
Really? Cannot.
Okay.
So it's all math lah.
Yeah. Once your line looks like a straight line, then your points fit around that straight line. And then, yeah, in your theory, you explain why it's a straight line. Then full marks.
So you smart. No wonder. Okay, I see if I.
Try to remember.
Yeah, I can.
Because there are some years that really you don't have enough time to finish everything.
Every year. Every time I hear senior say, you have time to finish practical lah. What is practical? 50%.
50%? No, not that much. I think 20 something.
That isn't good. So
Yeah.
practical isn't good.
Because it can affect your grade, definitely.
Just stick to 10%. Not that much. You don't affect that much. You have no.
So try not to rule out your practical.
that I don't want to. I just the very precise, you know. Then it tends to take time to be precise. No job.
Correct. Or worse still, Huh?
Just measure here.
which one? Distance from image to the center lens. Measure here, but also sometimes the scale is not correct. That means you can't use your ruler to measure because you look at the scale now. Make sure yeah, it's 25 for this amount of squares. Then you take this amount of squares and then calculate appropriately. Or worse still, like there was 1 year, I mean, okay, like every few years they will come up with electricity and you need to join the circuit.
It takes even more time, yeah.
So if you're super desperate, or unless you know what is the expected trend, because if you can't even complete the circuit, then you don't even have one data point at all, zero data point, no? No. If you are really, you know that time is running out, you just raise your hand and ask the teacher for help.
Already?
Yeah. They will help you, but of course they minus off a few marks, but I'm not sure how many marks they minus. Yeah, but it's better to having zero data point at all.
Isn't it even worse?
So you have to judge for yourself. Do you feel like if they help you, you still have enough time to get some points or not?
Data point is how much?
Depends on the question, maybe about 5 marks and then 5, 10 marks, but it's not just the data point, because the data point will determine the rest of the answers also.
You get the answer lor.
Unless you know what the whole experiment is about, and then you know how to answer without having data, then okay. Yeah, your practice.
Yeah.
Hmm?
How much question over there?
Two big question with many parts. Okay, good question. What does your school say? Do they care about SF? They do, Then what do they say? Did they want 3 SF or what? 3 SF, Okay, let's stick to 3 SF. Your school, 3 SF also, right?
Depends on the question.
Or do they ask you to look at the individual numbers?
Yeah, if you see the question, right, they put 3 SF, you put 3 SF, they put 2 SF, you put 2 SF. Because this is one time, right, the question put 2 SF in practical, and then I wrote 3 SF. As usual, you think it's 3 SF. Then macam mark me wrong, mark me down, and I have to redo the whole practical thanks. Quite stupid. Then imagine in practical, whatever practical you never see they wrote into SF, they write 3 SF, then you die.
Yeah. But this one is measurement, no? So how many SF should you have? Let's say I put 15 here. But you still need something, no? I mean,
usually. But then my students sometimes don't know,
so there's a way to do this stuff, but I don't think I'm going to tell you. Otherwise, it's going to be very complicated. Yeah. So don't want to complicate with all these numbers and SF thing. Finish what? Oh. No, go. Express. 180.
It's so much sugar.
180 only. You tell them 0 sugar.
What's the point of drinking 50 with 0 sugar? Let's drink at least half. Drink this and half already.
What are you drawing, Chloe? Correct. This one, This one, Wow. Yeah, you have to remember. I mean, you can draw, but it's going to take a lot of time, You remember the 6 scenarios, right? you still have your notes? It's going to take a lot of time. If you want to draw, it's going to be very constant consuming. Good. So you remember all six,
And since but then
remember the six scenarios, Chloe? Which scenario is that? Okay, it's the last one, number 6. This one. Yeah, because where's your object? Object is here, no? And it's before your focal point. F is here, but your object is in front of the F. So that's the tough part. I hate it, but you have no choice. You have to remember this 6. Or if not, you're going to lose that, I think, 2 marks, right? The question.
That's virtual and same side.
No, virtual is always enlarged. Come, Chloe,
it's 3 marks.
you have 3 marks, you see? Virtual, magnified, virtual, magnified. If it's virtual, it's always on this side, the same side as the object, or left-hand side. So far, I haven't seen a question to confuse you to put the object on the right side. They can know, but so far, they haven't.
It shouldn't.
Yeah, it's very confusing.
Well, on the focal point and diagonal. That one is undefined, right? I mean, infinity, right?
Yeah. Can Chloe take note? If it's virtual, it's always upright and magnified. Always, always. You notice, look at the other 4. The other 4 are real. Okay? Real, 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 real. But real can be diminished, can be same size, can be magnified. But it's always inverted if it's real. Always. Oh, not getting your express.
I cannot play them. What is too much sugar for me?
Oh. Let me see whether I can get a difficult question for you.
No thanks, Joe. No. The theoretic inverted is alright.
Sorry, say again?
ATERALLY inverted, is it upright?
Do you know what's meant by laterally inverted? That means left become right, right become left. Like what you see in the mirror. Inverted means top become bottom, bottom become top. They are different.
Inverted is opposite. So the theoretic inverted doesn't apply now. We only apply for plane 0.
Good question. Laterally inverted. Yeah, by right it doesn't. It doesn't.
I'm confused because bio they got right. Laterally inverted.
Just for the I.
Yeah.
But you have a point though. Let me think. No, they already told you it's inverted. Once you know it's inverted, it's always. Remember? Yeah. There are 3 properties. Real or virtual, inverted or upright, diminished or magnified. So it's always these 3 properties. But you also know that once it's inverted, it's always real. Always. Don't even need to draw lines. But if your legs are perfectly circular, you're right, no? It'll be laterally inverted too. If it's perfectly circular.
This is so hard. Dia purposely ask you.
Not yet. No, haven't seen it. Remember, there are the difficult questions for you. They combine lens and
Like,
no. I mean lens is like already lah. They combine lens and refraction, I think. Or lens and reflection. They put a lens there, then they put a mirror there.
oh, that you reflect back.
Yeah.
This
And-
draw equal angles.
Just make sure you're careful with your angles.
Unless they told you something very complicated that I can't understand. This time they asked a like question, right? Was really, really hard. I think it was WA1. Since we only learn light, wave,
Yeah.
then they gave us a very, very super hard. Oh,
But then everybody sure cannot do well.
yeah.
Okay.
Maybe it was hard. It's hard now because I not really familiar as I was like I learned just like
The other difficult question for you is for refraction. So far, most of the time it's talking about 2 media. They have 3. That means like air to water to glass or something like that. No, fraction. Then you need to calculate.
Well, imagine you calculate wrongly and then because the index
Yeah. You have
different.
different reflective indices. How can we? Okay. Cool.
Not a good idea to drink cold drink now.
Oh.
We can focal run video.
Where's this the focal length? This no hold on. This is horizontal. Then you go right to the your image is here. How come this one doesn't join the image? No, come. Sorry. What you should do is this. Let's say from here. Do you know where your focal length is? Focal point, you don't know. So, but what you do know, image is here. Get a ruler. Join this line to this. Okay, and then you do the same for all the rest from here because they all should converge on your image. Who mentioned Snell's law? Yeah, you know how to use it.
No. This one is here. Snell's law.
Which one is for refraction?
The angle of incidence. No. Refraction.
Refraction.
I'm sure I got one, but where you use it, I believe Huh?
Where is the Snell's law?
No,
No Snell's law.
it is. I think if it's in the textbook, then maybe got, but
But you didn't write the formula.
what's for fraction,
For Snell's law, it has a formula, no?
which is
Oh, okay, you're in trouble.
I'm in trouble.
Later I'll show you. Hopefully, don't say hopefully lah. I mean, after this, if it comes out, hopefully you can do it. Okay, good. Yes, good. You know why this like and not this or that, right? You know why? Because this one is the parallel. Okay, anyway, while she's doing it, I'll show you the formula. You better write down somewhere.
Minus 15 cm.
You're not supposed to know that, but
That's all. Yes, you are supposed to know, but it may or may not come out.
I don't remember.
Yeah, I know. This is refractive index.
Mm.
This is also refractive index. So in other words, when do you use it? When you have at least two different media. And probably excluding air or vacuum. So I'll give you a simple example. So let's say I have this. This is water and glass. Okay, they are not air, of course. Oh, okay, good, good. Make sure you remember. Let me just finish this with her first. So as always, if you have a light ray here, notice I don't even care whether it's going up or going down. Always draw the normal. Okay. So water has a refractive index, let's call it NW. Glass has a refractive index, NG. And of course, they have their own angles as well. This angle. Also, I don't care whether incidence or refraction, it doesn't matter. This is angle for water, angle for glass. Of course, make sure the angle is with the normal. So if I want to make use of it, I can rewrite my formula. Sign, I forgot to sign. So usually there's one unknown somehow. Like you don't know this angle, you don't know the angle, you don't know this refractive index, you don't know the refractive index, and you need to solve for it using this formula. Can try to remember. It may not come up. Okay, let's quickly go through the answers for here. All right, I think I've given you quite a lot of help, so you should be able to get it right. Draw the arrow to represent the image. Come, I just quickly take a look. The image is there, yeah, fine. Make sure it's upside down. Come, what's the distance? 36 cm. What do you get? Ming Ting? 38. Okay, if you read correctly, it's about 38 lah, but 36 can be acceptable. Do you get 1.5, Chloe? What do you get?
Okay.
1.43, yeah. Okay, close enough. All right, close enough. Now, I think I've already told you the answer for part C. Okay, make sure it's magnified, upright, and virtual. Okay, this one need to know. Okay, again, I've helped you quite a bit for this. All right. State one other property is real. What else? And yeah, you can also use enlarge. Okay, can see. Focal length. Ming-Ting, do you get your 15? You did, right? Okay, so magnification, you should get 1.5. Okay, you should. Oh.
I got very 1.45.
Can Chloe, any questions? I think your only thing is you have to remember all this. Because if you are guided, you know what to do, right? But let's say if there's no one to guide you, then you have to remember it. Okay, any questions about light? No? No? If not, I'll just start on one other topic that is only covered in Set 4.
Yes.
Oh, unless you're in some special school, then they will cover it first.
Yeah.
Yeah. Okay. Do you have your notebook with you, Chloe? Okay, let's start with the simple one. Actually, no. But it's the first chapter that you will be introduced to electricity. Okay, come static electricity.
So
The notes are.
so much for electricity.
Okay, so of course, when you talk about electricity, there's something called charge. It's either positive or negative. But what you need to know is it's due to electrons. Okay, so let's give you. Okay, hold on. Let me use this one. Careful.
Nothing.
Never mind, I will give you all the wipes and you wipe the whole thing. Okay. Okay, now it's just like your chemistry. You have your ion, whether it's cation, anion. It is positive, that means there's a lack of electrons. So let's say I have this thingy here, a ball, metal ball. So the whole metal ball is positive. Now, the reason is very simple because it has more protons than electrons. All right, so that's why it's positive. Now, again, I can also have another metal ball here, or whatever, can be any object, is negative or negatively charged. They mean the same thing. Now, of course, the reverse is true. It has more electrons than protons. Normally, this value is given, but sometimes normally it's given. But what you need to know, electron is charged, right? Negatively charged, right? There's an exact value for it. This is the exact value. Electron, one electron, minus 1.6 times 10 to power minus 19 coulomb. Now, I want you to remember this unit, coulomb. Anytime you see capital C, it means coulomb. It means it's a unit for charge. Now, the second thing I want you to remember, charge has a symbol as well. It's represented by Q. Units coulomb, but the symbol is Q. Okay, you have to remember that, no choice. Now, the third thing you need to know, how is charge related to electricity? Well, this is one possible equation that you need to remember. Current equals the charge over time. But, you know, like a lot of other equations or formulas can use symbols to represent it. Make sure you remember current is capital I, charge is capital Q. And time is always small t, don't use big T. So small letters, big letters, they mean different things. So be careful. Okay, on the other hand, there's something we call electric force. Remember your forces in your chapter 3 or chapter 4. Electric force obviously is measured in newtons. Make sure you remember that. That's our unit for force. So just like magnets, you have either repulsion or attraction. So if I have two balls like this, both of them are positive. Obviously, they are going to repel each other. Okay, so this is repulsion. But if I have two balls, one positive and one negative, no, of course they're going to attract. Okay, basic stuff, remember that. Now, let's go on. Then they have this term called electric field. Just like gravitational field. And you need to define what is electric field. This is your definition. Remember, it can come up.
We need to bring the textbook.
Which textbook? Oh, yeah. Okay, the one I highlight, it can come up. They ask you, define electric field. It's a region in space in which a charged object experiences a force. Okay, of course, the force is electric force. I mean, I didn't write it down, but it's an electric force. Now, in an electric field, you can draw field lines. And when you draw field lines, you have to give them direction. So, for example, let's say I have this case. Okay, come and just draw it for you again. Okay, very simple. Let's say I have two plates. One side is positive. One side is negative, negatively charged. Okay, now, in between these two plates is an electric field. And once you have electric field, you have to draw field lines. So I can draw horizontal lines in this case. It's up to you. I drew 4 here. You can always draw 5 or 6. It doesn't matter. But what is important is the direction. It's always from positive to negative. So draw directions for all the lines. So the more lines you have, the more arrows you have to draw. Okay, so these are the few. Make sure when you draw few lines, you must have arrows inside. But let's say within this field, I go and drop this small object here, which is positive. Come, Chloe, tell me, where will this guy go towards? Up, down, left, or right? Yes, good. So this is the electric force. And by right, for your answer, when they ask you to explain, you have to mention 2 things. This, okay, I just write out for you. Basically, your charge object is repelled by the positive plate and attracted by the negative plate. So you have to include both points by right. Some students, in fact, a lot of students will tend to forget. They just remember or repel, repulsion or attraction, but they forget the other one because here they are both sides. So both forces will be executed simultaneously. Okay, so I don't think I need to give you the example for the negative charge. I'm sure you can know how to explain. Okay, just a note. They like to use this word point charge. What does it mean? Point charge means you have a very small object and the charge is like a point. It's a very small point. Usually you draw it as one single sign, positive or negative. So the charge is concentrated at one single point, theoretically. So this is called point charge. Okay? Usually it could be a water droplet. It could be a very, very tiny plastic bead or something. Okay, it's a very small point, but yet it's charged. All right, so how about what happened? Okay, here I drew very nicely because these 2 plates are uniform. So therefore, look, my lines are uniform. But what if I only have one single point? This is what they call isolated point charge. Let me write down. Isolated point charge. So it's a single point. It's charged. But I also need to account for the word isolated. It is by itself. There are no nearby charged objects. But I still have to draw some lines, right? Because it's charged, I still have to draw a few lines. As long as something is charged, it exerts a field around itself. This is how you draw the field lines. Radially, in a radial direction. Up to you. Here they have drawn how many? 1, 2, 3, 4, 5, 6, 7, 8, right? 8. You can always draw 10, 11, up to you. The more lines you draw, the more arrows you need to fill in. Yes, good. So if it's negative, then the arrows are inwards. Remember, positive to negative. Okay, simple enough. Huh? But you notice something, no? Something pretty important. Huh? Look at here. How did I draw my field lines for these two plates, between these two plates? Parallel, uniform. Huh? So what does that mean? That means something, no? It means what? My field is, electric field is uniform. This one is more advanced. It may or may not come out. That also means if I put this guy here, yeah, just now Chloe already mentioned it moves to the right. But if I put a similar guy over here, it will move to the right too. But also importantly, both of them experiences the same electric force. As long as these two guys have the same charge. So they have the same electric force. To the right, of course, since both are positive. And let me emphasize, why are they the same? Because not only are they the same charge, they are also in a uniform electric field. That is why they experience the same electric force. Again, this question may or may not come up. Can I take note of that word? I mean, I highlighted all the important words. Uniform electric field. I like but okay, let me finish highlighting. Coming, but look at these two guys. Are the electric fields uniform? Yes. No. Yes. No.
Together.
I mean, okay, we look at them separately. Uniform?
Yes.
The answer is no. Non-uniform electric field. Uniform doesn't mean symmetrical. Now, essentially, okay, there's one more concept I didn't mention. There's something called electric field strength. This one may or may not come up, this concept. Electric field strength increases when the lines are close together. This concept in mind, again, may or may not come up though. So my question is this. Let's say you put a charge here. Now, where will it go? Yes, upwards. And yeah, too easy. Now, if I put a charge here, where would it go? Yeah, upwards too. But my second question is this. Do they experience the same force? So who experiences a stronger force? Above or below? Yes, is it above you? So basically, this is a stronger force. This is a weaker force. But I mean, I just give you the concept, but let's say this may or may not come up. Yes, you notice at this point, the few lines are quite close now. They are quite close. This is quite near, this is quite near, this is quite near. So few lines are close. That means field strength is higher. But when you come to this point here, where are the few lines? Oh, they are pretty far apart. Can see clearly, right? So now my few lines are here so far, no? So far. So the distance is so great between the few lines. So the field strength is bigger here. Electric field strength is bigger at this spot. And therefore, it results in a weaker force. You can see the few lines are becoming further as you move further from this central charge. Maybe I just redraw another version. So imagine I have this. So same guy. Okay, I just draw partially, just this positioning. You notice when it's close, let's say around this region, the few lines are quite close. But if you're at this region, the few lines are quite far apart now. You see, it's so far apart. This one is closer. So that means this region has a higher field strength or stronger, higher field strength. Whereas this region has a lower field strength. And finally, the moral of the story, the further you are from a point charge. Remember, this is a point charge. The weaker the field strength. Or let me be more specific, the electric field strength. Chloe can follow? Can I? Okay. Yeah, that's all you need to know. At least there are no formulas for O levels regarding this. Let me see. Anything else about that? Okay. Okay, the next thing. Now, whenever you look at an object, first question, is that material a conductor of electricity or an insulator? This can be important. Now, Chloe, give me an example of conductor. Electrical conductor? Yeah, of course. Metal, so make sure if you see the word steel, iron, copper, make sure you know that those are metals. Thinking insulator? Good. Good. How about graphite? Graphite seldom comes up. Let me think. These are the common ones. Anything else? Okay, but let's say give you some unusual one. How about, let me see. Hair.
No bad. Because you get
Okay, so yeah, sometimes they give you some unusual things, like hair, then it should be an insulator. But of course, I don't have a comprehensive list. Can I give you some examples? How about Chloe? How about balloon? They tell you give you a balloon. Beside this or this. Yep. Yep, you can come up on a balloon. Because they won't tell you, no, they'll just tell you the object. But you have to figure out, is it a conductor or insulator? Okay, now next. What's the difference? Oh, let me copy her stuff first. Done already, yeah? Okay. Let me see. How should I put? Oh, I forgot a few more things. Guys, I think I moved too fast. I forgot these two cases. Yeah, I moved a bit too fast. What if I have 2 point charges near to each other? How are you going to draw the field lines? Oh, by the way, they really can ask this question. This one? Pause it. Can take note. It can come up exactly like this, no? And they ask you to draw the field lines. Yeah, it looks like this. Positive and negative. Remember, field lines always flow from positive to negative. That is the direction of the arrow. Positive to negative. So of course, there's an electric field between the 2 points, obviously. And of course, anytime you have electric field, you must be able to draw the field lines. Notice there's a horizontal line also. Include that in your drawing. There's a horizontal line on the left as well. Now, guys, because there's not enough space, by right, this line, let me zoom up first. By right, this should join, just like this should join by right, if there's enough space. But if there isn't, that's why you don't see the upper part or even the lower part. Same thing, the lower part by right, they should join. The only 2 lines that don't join is this one, and this one. Okay, these two do not join. Now, why is this important? Because over the years, you know what students will draw? They'll draw something like this. Draw one, so no need to copy. Make sure you don't draw something like this. They'll draw something like this. Okay, positive, negative. Then of course they'll get this line correct, of course. And probably this line you'll get it correct as well. Directions are correct, but guess what happened next? Then they draw something like this. Okay, still correct, still correct. But suddenly they change. Did you notice a change in the curvature? Not that it's curving.
It will join.
Yeah, if curving this way, it will never join. So if your teacher is strict, which I believe she is, she will knock you wrong. So can see the difference, Chloe? Can. So make sure your lines are like this. The curve is like this, such that they can join. Not like this, not like this. You see the difference? Okay, so okay, I'm going to erase this. Make sure you don't draw this kind of curvature. The which one? Repel. Oh yes, of course I will. Now, what if I have two negative or positive point charges? This is how the lines look like.
What's the X? Point charge.
Yes, good. No, it's not point charge. Sorry. Take note, where's X? Occasionally they'll ask about X.
The off.
There is no electric field in X. That's important. I mean, sometimes, but not all the time. So they call it null electric field region. There's no electric field here. Also, reminder, notice how the lines curve. Do the lines join?
No.
Yes, that is the point. They will never join. So they curve away from each other. Do not draw the opposite. Okay, all the lines curve away from each other. I mean, except again for the horizontal lines. I hope you notice. Horizontal line, as usual, is to the left and to the right. Now, of course, I'm sure you realize there's a last case. So can you draw it on your own how to draw the electric field for the last case? So it's negative and negative. How will this look like? Except for what? But anyway, just draw it out and I'll take a look. How? Done? Okay. Okay, so far, but
It's good.
okay lah. I don't know how strict your teacher is, lah, but I think okay lah. For me, it's okay.
Okay.
Because they may want to see some lines here, so here.
Thanks.
That's a- They may want to see some lines here as well.
Oh,
Uh,
why would they want to see that? Like, must show that the
Because-
style.
I mean, it is not totally wrong because if they are very strong charges, then there'll be no lines here as well, no field here. Yeah. But if they're not very strong, then by right, the field will stretch all the way here as well. But
Okay.
okay lah, for me, I think it's okay lah, you can pass.
I still better job.
Oh, I didn't check your arrows are correct. Right?
Oh! It changed.
Yes.
So good. It's only changed.
Okay, good. Good news for O levels, maximum only, you need to consider only 2 points. They won't give you 3 or 4 points. Otherwise, you cry.
Okay.
Okay, I'm in how correct now. Let me double check. Okay, good. Be careful with your arrows. It's very easy to make mistake. Okay, so I don't need to go up for you, but let's go back to, let me see anything else I miss out. No. Okay, let's go back. This is material part, conductor and insulator part. Okay, what's the difference? Difference is this. Let me get some space. Let's say I have a conductor. Okay, let's say simple metal ball. Now, what happens is charges can flow through the object or flow in the object. Yeah, mobile. Of course, you know why from a chemistry point of view. But they won't ask about that though. All right, so in other words, okay, before I tell you the implications, let's look at the other case. How about this rubber ball? Of course, rubber ball. Charges cannot flow in the object itself. So the implication is this. Imagine I go and send attach a wire here. Okay, wire. And then I send electrons into this metal ball. So this metal ball will become charged positive or negative. Negative, electrons are negative. Remember that. So it becomes negative charge. Then I remove the wire. So the ball is, well, maybe suspended. Okay, maybe I don't use the word suspended. It is, let me draw something else. It is on an insulated stand. So it's not floating in the air. So it's on a plastic stand. The metal ball has a lot of electrons inside. Just now I given it quite a lot of electrons. What will happen next? Now, next, basically, the charges, whether positive or negative, charges will distribute themselves. In the metal ball. So in your exam, you cannot just draw electrons like that, no? You have to spread them up nicely, or your teachers will not be so forgiving. So I will put negative all over the ball. Inside as well. It's not on the surface only. Okay, they will distribute. But this one is different. Rubber ball. Can I attach a wire and send electrons over? No, I can't do that. I can't do that. I have to do something else. I have to use, let's say, a piece of fabric, maybe silk or something. All right, so I use a piece of fabric, wrap it. I cannot attach electrical wires. I can't use battery to charge it. I have to use mechanical force to rub on it. Okay, so what happens? Now, in this case, the fabric transfer electrons to the rubber ball. So this is the portion that I rub on. Therefore, I will have negative. Remember, electrons are negative, 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 negative. Over the portions which I rub on. Now, of course, I have to stop rubbing eventually, so I remove the fabric. But the charges are still there, no? The electrons are still there. Are the electrons going to distribute themselves? No. Okay, that is the important lesson you need to remember. They stay more or less within the same area. Drinking and follow up. And so please write down, I think I'm not going to write that down. Okay, charges do not distribute, they do not move around. But let's make things a bit more interesting. Let's go back to this guy. All right, remember this guy is negatively charged, huh? And then you decide to try something. You attach a piece of wire to the ball and attach it to the ground. It's going to come out. They like to play with this. They like to play with this. That's why static is quite hard, like static electricity.
So electrical force.
Yes, ground. But guys, can you remember the symbol for ground? Okay, probably not. Remember last time in your primary school, you learned this is your switch. Light bulb, battery. Now all this will be coming back to haunt you. Which thing? Remember think that time we have gone through how many symbols are there? 20, right? Okay, but anyway, ground. This is a symbol. 3 strokes.
Downwards.
Yeah, downwards. Must be downwards, cannot be outwards. 3 lines. Ground, or sometimes they call it earth. Now you need to understand what happens next. Yes, all the electrons will flow down because they can move through the ball. So until when? Until what happens? Until no more electrons. Okay, until the number of protons equal to the number of electrons. Basically, until it becomes neutral. Okay. So maybe you have to write down somewhere electrons will flow around till the ball is neutral or is uncharged. Okay. Well, of course, I can ask you the same thing for the rubber ball. Okay, so let's go back to our friend here, rubber ball. So let me attach a piece of wire, electrical wire, of course, attach it to the ground or the earth. What will happen? Nothing. The charges cannot move, electrons cannot move over. It is still charged on the left-hand side. Unless so far I haven't seen it coming up before. Unless you go and put a metal piece of metallic cloth. You know, you have some wire cloth. Go and put a whole piece of wire cloth around this area, or wire gauze, and then join it to the ground. I don't know, they are sometimes crazy, you know. Unless all the whole piece of wire gauze is in contact with your negative surface, then yes, your electrons can flow down. They must be in direct contact. But so far, I haven't seen this question before. Now, one more thing I want to repeat. Now, for this case, let's say electrons, okay, assuming I haven't done the earthing or the grounding yet, the whole thing is still negatively charged. Okay, all the electrons are around, inside as well, inside the ball. But this one, no. Assuming I didn't put the wire here, it's still charged. These charges are only on the surface. Remember that they are not inside. Okay. But I hope you know the opposite is true also. Because I started with the easier example. What if I have this? Let's say I have a metal ball again. Okay, then this metal ball is positively charged. And then of course, I put it on the plastic stand again. They like to do that. Make sure you also know what will happen if I join a piece of wire to the earth. Remember, earth is always inverted, long, short, shorter. Cannot be the other way around. So you think what happens? What moves to the ground? Protons cannot move. They are locked in the atoms. Only electrons can move. Current. You can use current. But I make it I present it in a simpler way. So what happens next? Let's ask Chloe what happened. What happened next if I join the wire to this positively charged metal ball? What moved to the ground? There are no such thing as positively charged electrons. Okay, there are a few ways to answer this. I use the obvious way first. Electrons will move up from the ground. Don't worry, this will be the last part. Remember, only electrons can move. Remember, the ground is like a big reservoir of electrons or a reservoir for electrons. But your teacher may want you to answer another way. Okay, you also can write this: positive charges move from ball to ground. Even though there's no such thing as positive charges. But this is an imaginary concept. Or, since you like current so much, currents goes from ball to ground. Now, there's a concept that you need to understand, even though it comes in later, but I may as well tell you now. Now, current, remember that always flows in the opposite direction to yes, always remember that. Since electrons go down, then, oh sorry, in this case, electrons move up, that means current must go down. Okay, don't screw that up. Make sure you get it correct. I know there's quite a few new concepts for you, but yeah, I think this will be a good point to end.
Okay.
Any questions?
No.
No? Okay, then that's all for today. Okay.
Thank you.